Newton's rings, determination of wavelength of light. So here our aim of the experiment is to determine the wavelength of given sodium light using the Newton's ring arrangement. Now in Newton's ring arrangement, it consists of a convex lens of large focal length nearly 1 meter and a glass plate. Now when this convex lens is placed over the glass plate, so that is arrangement of the Newton's ring, then now light from a particular source, say sodium light, is rendered parallel and that is allowed to fall on a glass plate which is inclined by an angle of 45 degree. So the light incident on the glass plate, and when this lens, the Newton's ring arrangement is placed such that the light incident on the reflected light, the light reflected from the coming light by the glass plate incident on the lens arrangement, Newton's ring arrangement, the Newton's rings are formed, and that Newton's rings are observed through a microscope. We are provided with a microscope, so we can observe the concentric rings, and by measuring the diameter of the rings we can calculate the wavelength of the light. Now coming to the theory involved in the determination of wavelength using Newton's rings. When the Newton's rings are formed by our principle, the diameter of the nth dark ring is given by the formula d, nth dark ring, d n square is equal to 4 n r lambda, where r is the radius of curvature of the lens used and lambda the wavelength of light used. So that is equation 1. Then we can write the diameter of say n plus kth, say let k is equal to 10. Then n plus kth dark ring can be written as dn plus k square is equal to n becomes n plus k, 4 n plus k r lambda. So from the equation 2 and 1, if we subtract 1 from 2, we are getting dn plus k square minus dn square, that is equal to 4 k r lambda. Now from that we can find the value of lambda as dn plus k square minus dn square divided by 4 k r. So this is the formula that we use for the determination of lambda. That means by measuring the radius of curvature r and the value of the diameter of nth ring and the diameter of n plus kth ring, the square of the diameters are measured. From that we can calculate the value of lambda. Now coming to the experimental setup, now the Newton's ring arrangement consists of a convex lens of large focal length which is placed over a glass plate. So that is a Newton's ring arrangement. The light from a source which is rendered parallel or parallel beam of light is allowed to fall on a glass plate which is placed inclined by an angle of 45 degree. Now the light is reflected here and that is rendered falls normally on the lens. Then on the lens in between there is an air film is there. Light reflected from the lower surface and upper surface of that air film interfere, and then the interference pattern is formed, and that pattern formed over the Newton's ring arrangement can be observed with the help of a microscope. That is a microscope which is held just over the glass plate focusing on the lens. So that is the arrangement. Now when we observe the ring, we can observe a pattern like this, like now this is the pattern usually we are obtaining. The center spot is supposed to be perfectly dark. Sometimes we are not we are missing the center spot. The center spot appears sometimes bright. Then this is we can see a number of rings. Now this is the first ring. Now here the vertical crosswire is coinciding over the first ring in the left side. Then the second ring right side, third ring, fourth ring, and we can count a number of rings in the right side. Similarly, we can have the same ring on the left side, that is the ring is there. Now we want to take the reading corresponds to each ring. So we are starting from the left side, we are moving to the 20th ring or 25th ring, then move over to the 20th ring. So here we are, the vertical crosswire is fixed over the 20th ring. Now using the tangential screw of the microscope, it is made coincide on the 20th ring, take the MSR and VSR ready. Then move over to using the tangential screw, move over to the 18th ring, take the reading, 16th ring, 14th, 12th, 10, 8, 6, 4 and 2. Now we have obtained the second ring, we obtained the reading. Now moving the tangential screw again, we are moving to the right side, the second ring, fourth ring, sixth one, eighth one, 10th, 12, 14, 16, 18 and 20. So we are moving up to the 20th ring on the right side. Now all the readings are taken with the help of the microscope. So when we are taking the microscope reading, we can see on the microscope. This is the main scale of the microscope. Here we can see the reading 9, 10 and 11. Now from 10 to 11 on the main scale there are 20 divisions. So value of 1 division after 10 it is not 10.1, 10.05, 10.1, 10.15. So the value of 1 main scale division is 10 by 20 or 0.05. Similarly, this is the vernier. Now the vernier is having 50 divisions, but usually it is marked say 0, 0.1, 0.2, 0.3 etc. Actually it is 10, 20, 30, 40, 50 etc. So 50 divisions are on the vernier. Now here for a sample, here in this particular case you can see the 0 of the vernier is coinciding or not coinciding, completed. Now this is the 9th one, and this is the 9.05, 9.1, 9.1, 9.2. Now the 0 is just after the reading 9.2. So the MSR reading is 9.2. The MSR reading is 9.2. Now on the vernier you can see here. So now the 6th one. Now look at the 6th one. This is the 5th one. Now the 6th one. The 6th one is perfectly coinciding. The 6th one is perfectly coinciding, and that is the VSR reading. So in this particular sample example, the main scale reading is 9.2 and VSR is the 6th one. 6th one is coinciding. So the total reading is 9.2 into 6 into 0.001. That is the least count. So obtain the total 9.206. Now least count is calculated using the formula value of 1 main scale division, that is 0.05, divided by number of division of the vernier, that is 50. 0.05 divided by 50, that is least count, that is 0.001. So we obtain the reading corresponds to all the rings in the left and right. So we have the tabular column. Now this is the tabular column that we used to find the diameter. Now here, now we start from the 20th one. Now for the 20th ring, MSR, VSR and the total is calculated. Then for 18th, 16th, 14th, 12th, 10, 8, 6, 4 and 2 of the left side is completed. Now we are moving to the second ring of the right side. So we are starting from here. 2, then we are taking the MSR corresponding to 2, then MSR reading corresponds to 4th one, 6th one, 8th one, 10th one up to 20 of the right side. MSR and VSR is taken, then the total is calculated, that is B. So left side reading total is A and the right side reading total is B. So A difference of B for the 20th gives the diameter of the 20th ring. The B difference of A, B is the reading of the right side, A is the reading of the left side, B minus A or A difference of B, A difference of B gives the diameter of the 20th ring. So here we are getting the diameter of the 20th ring. Similarly, diameter of the 18th ring, diameter of the 16th ring, diameter of the 14th ring, 10th one up to the diameter of the second ring. Now from that diameter value we can calculate the value diameter square, D square, and from again D square we are calculating. Now take K is equal to 10, then find the diameter of the 20 and diameter of 10. So dn plus k square minus dn square we can calculate. Then we obtain the value of, that is a constant, dn plus k square and dn square. We can obtain the value, mean value of dn plus k square minus dn square. Now to find out the focal length of the lens by a plane mirror method we are using. We are keeping a plane mirror, the lens in front of an object, and behind the lens a plane mirror is placed so that the image of the object is formed side by side with the object. The image of the object is formed side by side of the object with the help of a plane mirror placed behind the lens, and that distance is noted, and that distance should be the focal length. It is repeated 3 times and the mean focal length is determined. Similarly, by Boy's method, if we keep a black paper or black cloth behind the lens, and if image of the object is formed side by side, that distance is D by Boy's method. So that also determined 2 or 3 times. The mean value of D is taken. Using that value of F and D, we can determine the value of R, FD divided by F minus D. Now using the value of R and dn plus k square and dn square, and we are a known value of k, that is 10, we can determine the value of lambda, that is dn plus k square minus dn square divided by 4kr. The lambda of the light used can be determined. Now in the experimental setup of the Newton's ring formation, we already mentioned the Newton's ring apparatus consists of the convex lens of large focal length placed over a glass plate, and another glass plate is inclined by an angle of 45 degree. The light from a source, now a sodium light is used here. The light from the source is falling on the glass plate which is inclined at 45 degree. So, a part of the light is reflected at 45 degree normal and falls on the Newton's ring arrangement. Then looking through the microscope, we can observe the Newton's rings form. Looking through the microscope, now I am getting the rings here. Now using the fine adjustment tangential screw of the microscope, I can focus on the rings so that the rings are clearly visible. Now here I am getting a large number of rings. Now you have to find out, or you have to make sure that you are getting almost 20 or 25 rings to the left side and 20 or 25 rings to the other side. For that, the other horizontal screw of the tangential screw of the microscope is moved. Just count the rings. Looking through the microscope, you can just count the rings. Now I am moving to the left side. I can just count the rings. Say ring 1, ring 2, ring 3, ring 4, 5, up to 25 I am taking. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 and 25. So, I am getting almost 25 rings in the left side. Similarly, just find out that much rings are in the right side also. To start the readings, fix the microscope screw tight, and we can rotate the fine adjustment tangential screw. Just move in one side mean now I am moving the clockwise direction. Now it start moving in the clockwise direction. Now fix the vertical crosswire over the 20th ring. I want to fix the vertical crosswire over the 20th ring. Now the vertical crosswire is fixed over the 20th ring. Now I can take the reading of the microscope, the vernier reading and the main scale reading. Now here I am getting the main scale reading 5.95. The zero of the vernier is coinciding at 5.95 completed, and the 40th division of the vernier is coinciding. So the VSR reading is 40. So the total reading is 5.95 and 40. So I obtain 5.990 the total reading. Now looking through the microscope, I am moving to the, now remember you have to rotate in the clockwise direction alone to avoid the error. Now it is again rotated in the clockwise direction so that the vertical crosswire coincides over the 18th ring. 18th ring. Now it is coinciding on the 18th ring. Now I can take the reading. Now again I am obtaining the MSR reading as 5.95 again, and the VSR reading is changed. Now the 25th division is coinciding. So the total reading is 5.95 and 25. So the total is 5.975. 5.975 the total microscope reading. Now again it is moved to the 16th ring. Now it is moved to the 16th ring. Now the tangential screw is adjusted. The crosswire is constant in the 16th ring. Then I am taking the reading, the main scale reading. The main scale reading is 5.95 and the vernier reading is 0. So the total is 5.950. Now I am moving to the 14th ring. Now 14th ring. Then I am taking the reading. The MSR reading is 5.9 here and VSR reading is 32. Now I am moving to the 12th ring. Now it is 12th ring. The MSR reading is again 5.9 and the VSR reading is 12. It is marked. Then I am moving to the 10th ring of the left side. Now it is on the 10th ring. Now the MSR reading is 5.85 and the VSR reading is 35. It is noted. Now I am moving to the 6th ring. 6th ring. Then I am getting a reading of MSR. MSR is 5.8 and the VSR is 20. Now the 4th ring. Now the 4th ring. MSR reading is 5.75 and VSR is 40. And the second ring of the left side. The second ring of the left side. Then the MSR reading is 5.6 is reading and the VSR reading is 36. Now I am moving again from the left to the right side. I am moving to the second ring of the right side. I am moving. It is rotated in the same direction only. The second ring of the right side. Now it is on the second ring on the right side. So I am getting the reading of the second ring of the right side. So the reading is 5.5 is the MSR reading and VSR reading is 40. 5.5 and 40. So the total reading is 5.540. Now in the right side I am taking the reading corresponds to 4. Fourth ring I am taking the reading. Now the MSR reading is 5.45 and 35. Then again the sixth ring I am taking the reading. For the sixth ring I am taking the reading. MSR reading is 5.45 and 0. Then the eighth ring I noted the reading MSR and VSR. Similarly take the reading corresponds to 10th one, 12th one and 14th one, 16th, 18th and 20. So on the right side we started from the left side to the right side. We have taken readings of the 20th ring in the left side up to the 20th ring in the right side. Using that readings we can calculate the diameter, and from the diameter we can determine the wavelength. Now for the determination of the focal length of the given lens by a plane mirror method, now we are having an object here. The light from the object, a wire gauze is illuminated, that falls on the lens is placed here. Now just behind the lens we place the mirror here. Now what happens that, now it is a distant object, the mirror renders the rays coming to the other side parallel, and that rays are reflected back by the mirror. So it is reflected back. Then we are getting an image of the object here. Now we can see the image here side by side. Then this distance between the lens and the mirror, so the lens and the object should be the focal length, because actually the mirror behaves like to provide a distant object for the lens. So the lens is forming its image at the focus. So we can see the distance is nearly 1 meter. Now 101 meter is here. So the focal length of the lens is 1 meter. Now we can just repeat it one or two times again to find out which is more clear image. Now I am getting one more image, it is little more clear. So the distance is again measured, that is again nearly 101 centimeter. So it is repeated 3 times and find the focal length of the lens. Then by the Boy's method to find the radius of curvature of this particular lens, now the lens is behind the lens a black paper or black cloth is placed, and then it is mounted on the stand. Then we can see the image. We have to form the image here. Again as in the earlier case we have to get an image that is side by side with the object. Now we can see on the screen an image is formed. Now fine, when the wire gauze is clear. Now the wire gauze is almost clear. Now the wire gauze is almost clear. So that is known as the Boy's method. Here we are getting the value of D. Now here I obtained the D value nearly 50 centimeter, the D value. Now again repeat it for another position so that the wire is little more clear. Now it is little more clear here. The image formed here, that is little more clear. Now the distance is 51 centimeter. Once again it is repeated to obtain the side by side image, that is again 50 centimeter. So from that value we obtain the value D, and from using D and F the R is calculated using the formula R is equal to FD divided by F minus D. Now coming to a sample set of reading for the Newton's ring arrangement, we mentioned we have seen that for the microscope the least count is value 1 main scale division 0.05 divided by number of division of the vernier, that is 0.001 centimeter. Then for the microscope, for the 20th ring on the left side we obtain the MSR 5.95, VSR 40, total 5.990. Then for the 18th one the MSR is 5.95 and the VSR is 25, total is 5.975. Then for the 16th 5.95 and 0 5.950. Similarly for 14, for 12, 10, 18, 6th and 4th, and for the second one we obtain the microscope reading. Now we move to the right side. For the second one, in the right side the MSR reading is 5.5 and 40, so the total reading is 5.540. Now we move to the fourth one of the right side, 5.45 and 35, that is 5.485. Now we move to the sixth one of right side, 5.45 and 0. Then eighth one of right side, 10th one of right side, then 12th one, 14th, 16, 18, and we end at the 20th ring on the right side. So we started from the 20th ring on the left side and we completed the reading at the 20th ring of the right side. Then, so this reading is total is A here on the left side and the total is B on the right side. So we are calculating the difference 5.990 minus 5.290, that is A difference of B, that is 0.7. So this 0.7 is actually, that is in centimeter, 0.7 centimeter, that is the diameter of the 20th ring, that is the diameter of the 20th ring. Similarly, the diameter of the 18th ring, the left reading is 5.975 centimeter and the right reading is 5.304 centimeter. So the difference is 5.975 minus 5.304, that is 0.671 centimeter. Similarly, the diameter of 16th, 14th, 12, 10, 8, 6, 4 and second ring is determined. From the diameter we find the value of diameter, the square, d square is calculated, and then now we are taking a difference of say 0.4900, that is the 20th ring, and the 10th ring, so that k is equal to 10. So that is the value of dn plus k square minus dn square. So the difference of 20th ring diameter and the diameter of the 10th one, so that is 0.2460, that is dn plus k square minus dn square. Similarly, the 18th and 8th one, 16th and 6th one, 14th and 4th one, 12th and 2nd one, we are getting the dn plus k square and minus dn square, and the mean is calculated, that is 0.25918 into 10 to the power of minus 4 meter square. Then we obtain using the Boy's method, the mirror method, plane mirror method, we obtain the focal length 3 times 100 centimeter, 105 centimeter. So the mean is 105 centimeter or 0.105 meter. By the Boy's method, we obtain the d value nearly 52 or 53 centimeter. So that is 0.5225 meter. 0.5225 meter. That is the radius. Diameter is determined. Diameter is determined. Then we can calculate the value of radius of curvature r. R is calculated. Then lambda is determined. Using the formula, we obtain 5.8947. That is our result.